Hello guys, welcome back to Academic Coordinates. This is an example video. We are doing examples, we are doing exercises as far as series is concerned and sigma notation. Okay, cool. So let's look at number A. We are supposed to expand this, right? I first want you guys to take note that you might be like, okay, where am I going to substitute the k is equals to 1? Just take note that, guys, there is k here to the power 0, right? So any number to the power 0 is 1. So that's why you don't see the k, So just for this question, I'm just going to put the k everywhere, when I substitute my values there. So it's going to be half multiplied by 1 because of you are starting at 1 plus half multiplied by 2 to the 0 plus half multiplied by 3 to the 0. Then the last one plus half multiplied by 4 to the 0. So just look at it, guys. I mean, let's face it. This is the same as 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 2. Right? So what is the value here? The denominators are all the same. So 1 plus 1 plus 1 plus 1 is 4 divided by 2. This equals to 2. So we're able to expand the sigma notation and we're able to get a value at the end, right? Let's look at this one. So the lower bound there, we are starting from k is equals to negative 2 up until 2, right? So we're just going to substitute, right? So basically it's negative 2 plus negative 1. So remember that we are increasing in steps of 1, right? Plus 0 plus 1 plus 2, right? So we are done, So negative 2 minus 1 is negative 3. Negative 3 plus 0 is negative 3. Negative 3 plus 1 is negative 2. Negative 2 plus 2 is 0, right? So the sum of this is 0 right here. Okay, cool. Let's look at this one now. So we've got 0 to the x. So 0 raised to the power, that is still 0, Okay, but for the sake of this, exercise, let's just do it. 0 to the 3, we're starting at 3 right here, plus 0 to the 4, plus 0 to the 5th, plus 0 to the 6th, right? So this is the same as 0 plus 0 plus 0 plus 0, which is 0. I mean, like, hey, Okay, let's look now at number D. So when we expand number D, so it's going to be 2. We're starting at 1 times 1 plus 1 plus 2 times 2 plus 1 plus 2 times 3 plus 1 plus 2 times 4 plus 1, right? Can you guys see that? Okay, so 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. 2 times 3 is 6 plus 1 is 7. 2 times 4 plus 1 is 9. Right? So I think you guys can see that this is an arithmetic series, right? Because there's a constant difference, and the difference is 2. So 3 plus 2 is 5, plus 2 is 7, plus 2 is 9. But well, we're not asked that. Let me just grab a calculator to calculate these things. So please don't be embarrassed as well if you do that. So 3 plus 5 plus 7 plus 9, that is 24, right? So the calculator cannot lie. I mean, let's see. Okay, 5 plus 7 is 12 plus 3 is, okay, 15, then plus 9 is 24. Yeah, that's it, guys. Okay, cool. So let's look at this one right here. So the lower bound there, we're starting from k is equals to -2 until 0, you know. So this one is the same as the one up there. There is k to the 0 right here, but then we don't really bother to write it. So for this one, I can just say 7 times, no, I'm not starting from 1, I'm starting from -2 to the 0 plus 7, -1 to the 0 plus 7, 0 to the 0. You know what I'm saying? Okay, so basically it was not necessary for us to do this, but well, I just did it. So this is 7 plus 7 plus 7, right? 7 plus 7 is 14, plus 7 is 21. Yeah, I know something. Okay, so we look at this one. So we've got CA right here, and then we're told that A starts from 1. All right, so it's going to be C times 1 plus C times 2 plus C times 3 plus C times 4 plus C times 5, right? So 1C plus 2C, that's 3C, plus 3C, that's 6C, plus 4C, that's 10C, plus 5C, that's 15C. So it all boils down to this. All right, do you guys get it? Yeah, am I right? So I get 5 plus 4 is 9. This is 12. This is 14. This is 15. Yes, it's 15C. Okay, we come to this one now. Okay, so as far as this one is concerned, I want you guys to take note that this could have been expressed as 1 divided by 3 to the k, right? Trust you guys are aware of that. If you are not, now you are. Okay, so but I can still write it like this, you know. Yeah, so 3 to the -1, I'm starting from 1 here, plus 3 to the -2 plus 3 to the -3, you know. So as I've said, that this is the same as 1 over 3 plus 1 over 3 squared plus 1 over 3 cubed, right? Okay, so this is 1 over 3 plus 1 over 9 plus 1 over 27, you know. So yes, okay, let's see. I think you can use your calculator there to find this. Yeah, lest I embarrass myself any further, just use your calculator to, you know, to get this. Or let me just take it the old school way. So this is gonna be 27 multiplied by 9 plus 1 multiplied by 3 multiplied by 27 plus 1 multiplied by 3 multiplied by 9 multiplied by 9. So this is the old school way, guys, you know, don't take me that seriously here. Then you multiply everything together, right? Then you'll find your answer. Let me just use my calculator. I'm just gonna type it like this. You don't have to do this, so it's just being dramatic, you know. So okay, so 1 over 3 plus 1 over 9 plus 1 over 27. Okay, according to my calculator, that is 13 over 27, you know. So you guys are still in matric, so I mean, you can use your calculator, unlike when you come to university. Okay, cool, guys. Now let's take it one step further, right? Okay, so here we are told to write the following geometric series in sigma notation, you know. So there is a series that we are given, and we are told that is geometric, right? So initially our A is 1 over 9, right? Since it's geometric, we know that R will be T2 divided by T1. This will be our R. We are told it's geometric. We are not testing anything now. We know, or we are told that it's geometric. So 1 over 3 divided by 1 over 9. This is 1 over 3 multiplied by 9 over 1. Right, so this is 9 over 3. There is it. It's 3 right there. You know what I'm saying? Okay, so we need to express it in sigma notation. But first we need to find Tn. Tn is going to be, A is 1 over 9. And then, you know guys, that Tn is equals to A r to the n minus 1. So r is equals to 3, right? And then to the n minus 1. So now when you write it in sigma notation, we're going to put our Tn here, 1 over 9 multiplied by 3 to the n minus 1. Now, just for safety's sake, guys, you can put all of this in brackets, you know. Then our n will start somewhere and end somewhere. You see? Okay, let's check it right here. If n starts from 1, let's say I put a 1 here. So 1 over 9 multiplied by 3 to the 1 minus 1. 1 minus 1 is 0, right? So 3 to the 0 is 1. Then that's 1 over 9. And that is the first term there. So n actually starts from 1 and ends at 4, you know? Okay, so that is how you guys do this. Yeah, do stay blessed and enjoy the rest of your day.